All right, I guess we can get started. How is everybody doing so far at the conference? Good? Good? Cool. So we're here to talk about DirectX and Visual Studio. My name is Rong Lu, and I'm a program manager on the C++ team, and specifically focusing on graphics tools in Visual Studio. So our team owns graphics diagnostics tools. We own project templates for DirectX. We own the shader compile inside VS. And we also got a bunch of the asset authoring tool inside VS. So it's a bunch of tools focusing on DirectX development in Visual Studio. So I'm happy to be here today to share with you some of the latest development we have put into Visual Studio and show you a few demos. Just to set expectations, this talk is going to be focusing on DirectX 11 toolings. You have seen talks about DX 12 and what's coming. We're still working on the tooling, so I don't have that to show you today. The second thing is this is primarily a tooling talk, so I will not be talking about a lot of things in the DX runtime itself. It's going to be focusing on Visual Studio and how you use a tool to do DirectX development. OK, agenda, pretty straightforward. A little bit on why DirectX. And then we'll dive into Visual Studio 2013 and update to what is in there for you to do DirectX development. And we're going to spend a bunch of time in Visual Studio and do demos. And I'll take questions at the end. Sound good? Good. Before I dive in the content here, can you give me a quick show of hands? How many people are already doing DirectX development? Oh, that's most of the audience here. And I assume the rest of you are just wondering what's happening here and just curious to see. OK, sounds good. Oops, the wrong machine. All right. Anybody can guess what this is? Anybody? Yeah, Halo fans? Yes. So this is a game actually available in Windows Store and Windows Phone as well. Of course, when we talk about why DirectX, gaming is the probably first thing that comes to your mind. Halo Spartan Assault is a version that is made for store and phone. So when you do a game like this, which used to run on console, and you have a lot of the powerful hardware there, and you move that to Windows Phone, something this small, you still want to get the performance out of the hardware. You want to provide users the best experience that Halo fans used to love. So when you're dealing with games like this, DirectX is probably the way to go. There are two things I think that are the benefits of using DirectX. One is, of course, performance. It gives you full control of everything you do in your app. You are not constrained by any middleware or other people's code. You have the full control. Especially when you deal with Windows Phone and low-end devices, you want to get the best performance out of the hardware. The second thing is when you directly interact with hardware, when you want to do something fancy, like you want to use Kinect, you want to use a 3D printer, or anything like that, DirectX and C++ is probably the way to go in those situations too. So this is about gaming. And anybody can guess what this is? Some other apps that's not a game, for sure. Yes. This is Bing Maps. This is another app that's available in the store. This is Bing Maps Preview. And yes, this is Microsoft Campus. And this building is actually where our C++ team is located, building 25 back in Redmond. Again, another example of DirectX being used, this is not a game, but when you are dealing with a large scene 3D rendering, you probably want to go with DirectX. This is a paint app. You probably would not have guessed it's using DirectX. Anybody has seen this? Yes? Fresh Paint, another app that's available in store. This is actually a XAML and the DirectX interop app. So as you can see here, the rendering surface is all DirectX, but all the controls above are all XAML controls. So this is nicely outlined where DirectX is useful and how you can combine that with the XAML controls you love to get the productivity you want. So this is a combination of the best of both worlds. Last one. Anybody? Project Spark. Another pretty cool app that's in the store. This is also available on Xbox too, I think. So it looks like a game. It is, kind of. But the result of your playing is actually you are creating a game that can be played by other players. So this is an easy way for you to create games, actually. This is for creators to play and players to create. This is completely built on top of DirectX. And when you're rendering 3D scenes like this, DirectX is the way to go. So I just showed you a couple of examples of DirectX being used in Windows Store and phone. And now we are going to dive into Visual Studio and see what kind of tools we have there for you to help you with your DirectX development. So in 2013, the first category of features we have is to help you get started. Of course, we have templates for DirectX apps. We have also shipped a number of solutions that are served as samples. These are not in the box, but they are available for download from the web. I have pointers to at the end and to these downloads, and you can use. The second category we have is actually to help you to do graphics assets authoring. So when I say graphics assets, think about textures you want to use in your app, your 3D models, and shader code. And we actually have designers for each of these things in Visual Studio, in case you don't know. We actually shipped this first version in 2012. So if you're using 2012 or 13, you have access to those features. We also have content pipeline. Think about when you have your original source file for your assets, you wanted to convert the format into a runtime format that's optimized for your runtime. You wanted to go through a content pipeline. So we have built-in content pipeline in Visual Studio for image, for models, and for shader code. And last but not least, if you are coding HLSL directly in VS, you can actually compile inside VS. You don't have to use a separate compiler. It's all built inside VS. The last category, which is pretty important, when you do DirectX development, you probably want to have a debugger. Just like if you're writing code, you want to have a code debugger. If you're doing graphics, you want to have a graphics debugger. That's what we have in 2013. The debugger actually supports both desktop and Windows Store apps. There are a number of improvements we made in this debugger in 2013 that I'll be able to talk in details a bit later. And I want to talk a little bit about what's new in Update 2. How many of you have installed Update 2 already? 6, 7, 8? OK. If you have not, I will definitely encourage you to do so. A lot of features we're bringing in this update. I think this is the first update that we have done so much feature work, it's definitely worthwhile downloading and trying it out. I want to highlight a few things we are doing in Update 2. First of all, Windows Phone apps. So a lot of energy has been put into this release for us to support Windows Phone 8.1 development. So we added templates for it, and you have heard the universal Windows app. There's also work being done to support DirectX applications as well. On the graphics debugger side, of course, we have extended our debugger to support debugging on Windows Phone 8.1. Seems like a pretty good picture of tooling offer. Anything that's missing? Yes. Yes, we have a profiler now. So one of the things customers have been asking is a profiler for graphics apps. Now we have one. In this update, we shipped the first profiler feature, which is called graphics frame analysis. I'll be able to show you a demo later in this talk, but, well, we have a profiler now. So in this talk, I'll be focusing on the first and third categories. The reason is because the modeling, the authoring features we already have in 2012. If anybody wants to talk about it or see a demo after session, I'll be happy to do so, but I will not have time in this talk to show you all those features. All right, getting started. As I mentioned, in RTM, we have refreshed DirectX project templates for Windows. In Update 2, we added templates for Windows Phone. And we have added this universal project to target both Windows and the Windows Phone. OK, so we're going to do demos now. So the first demo I want to show you is how to build a Windows Phone, a DirectX app for Windows and Windows Phone. So there are two things I want to show you. One is if you start from scratch, like if you're new to the whole store and phone development, you want to build something using DirectX, you can start with project templates. And the second thing I want to cover is assume you have an existing app that's, let's say, either targeting phone or store. How do you make that universal? So let's start with the first one. This is Visual Studio. I'm going to show you quickly the templates we have. So if you go to Visual C++ Store Apps, we have two templates for DirectX. One is for pure DirectX, and the other one is for DirectX and XAML interop app. We have those two for universal projects, as well as phone only or Windows only. So you can choose from those templates. I want to show you real quick how this template is organized. And okay, in fact, let me run this for you real quick so you see what it does. It's pretty simple. If anybody has used the templates in Visual Studio before, it hasn't. The app itself hasn't changed much, but we have changed a lot around how the project is organized, hopefully to make it easier for you guys to get started. So it's a 3D spinning cube. You've seen that, right? It's actually interactive. So this is completely DirectX. And on the right corner, it says hello from XAML. This is rendered using XAML. So it's showing you how to combine DirectX with the XAML overlay on top. All right. So I'll show you a little bit about the structure here. So if you look close at what the default project looks like, it has two heads. One is for Windows, one is for Windows Phone. And there's a shared node, which you can put all of your shared source code into. So out of the box, if you run this Windows node, it's the spinning cube we have seen. if you run the Windows Phone node, it's going to launch the emulator or device and have the same spinning cube, basically. Now, the interesting thing here is how much code is actually shareable for an app like this. For a DirectX app that interrupts with XAML, how much code is shareable? How much code I have to write uniquely for each head? So the way the template, the default project is organized, actually all of the DX code is 100% shareable here, or in the shared node. So we reorganized the project just so it's a lot easier to know where you should get started. So under common, these are the DirectX device initialization and the regular setup code you don't have to worry about, usually. And then there's the content folder, which you can see all the files here start with simple. So you know these are the ones you should replace with your own file. So a couple of things we have here to showcase to you how to do 3D render and the FPX text to show you how to render text. And then we have very simple sample shader code as well here. So everything is here. This is the main app file. And then in each head, it's actually super simple. It has a number of assets that are unique for each platform. Like splash screen is a different resolution. And then the XAML files. By default, we create them in each head because you probably want to reconfigure for different form factors. But although this is how it's created by default, you can actually move those files into shared if you decide you don't want to do anything unique for each platform. OK, so this is the template. And then now I want to show you an existing app. How do you make that universal? So in the keynote yesterday, there was a demo showing how to take a .NET application and from Windows and make it universal and to target both Windows and Windows Phone. So you might be wondering, OK, then what's the story with C++ and DirectX? Can I do the same? So good news is, yes, you can. So this is, here's how it can be done. It's basically very similar. I want to run this for you first. This is, again, a XAML and DX interrupt app. So this, as you can imagine, is using DirectX to render a pretty cool way to look at photos. And there are a few additional screens called TV screens that are showing different angles. And you can actually see, as I rotate pictures, their rotation here. Pretty cool stuff, huh? And on the left side is a list of buttons. And these are actually built using XAML. And it gives me some controls of how many, for example, how many objects are rendered on the scene. Now I change that to 128. So you can see the interrupt between XAML and the DX. Now this is an app I have already on Windows. Now how can I make this universal? One thing to mention is that if you look at the structure of the project, it's based on the project template, but it's not completely 100% matched. So the files have been moved around, and you probably notice there's no shader code here. So I got a bunch of C++ and header files here, but there's no shader code. The reason is because this existing app is actually using a static lib, which think of it as the game engine I'm using. So the shader code is being handled completely on that side in the static lib. So I can show you that. This is the lib I'm using. It's called Spirograph. These are the compiled shader files. This is the lib file. So basically, this existing app does not completely match to the template, but I can also make it universal. OK, now I'm going to start. First thing to do, go to right-click and go to context menu, says add Windows Phone 8.1. So do that. This says it's going to add 2 projects to my solution. OK. Now, basically, those 2 nodes are added. The structure-wise, it's the same as the universal project if I use the template to create. But one thing you'll notice is that the shared folder is actually empty. So all the flexibility is in your control now. You can decide how many code you want to share. And you can share as much as you want or as less as you want. We figured we don't want to, if you start with existing apps, we don't want to mess up with your code and try to guess what code you want to share. So we give that control completely to developers, to decide what code you want to share. OK, so let's deal with the Windows version first. So I have a bunch of assets I'm using, which is these texture files are the ones I am loading into the picture viewer in my app. So these ones can be completely shared. So I'm going to shared and create a folder. It says assets. And I'm going to move all these files over. I'll leave these logo files there. The second thing I wanted to do is to move the code files. I'm going to move this. Demo animations, this is doing the animation when I click on the picture, it's rotating. And I want to use move the scene objects, which are the ones that create objects on the screen. And the main files, the timer, and TV screens. I'm going to move all these to shared. And what's left here? The XAML files. So as I said, you can leave the XAML files in each head if you want to customize, but you can also share. So that's what I'm going to do here, is I want to share the same XAML files. OK, I think at this point, I should run this and see if I break anything. OK, still works. Good. I did not break anything. Now, I am going to go into the phone project. So just take a look at what has been created here. Again, nothing secret. The same assets for splash screen and logos. And the only files that has been created here are XAML files. So since we are going to use the shared version, and I don't need the main page, which comes by default, I can delete that guy, remove. And one thing I need to change in the file is replace main page with DirectX page, because that is the name of the shared version. And I need to find where main page is mentioned, is being referenced, and just replace with that. OK, now this is going to use the shared version of XAML file. Last thing I need to do is make sure the Windows Phone version is also referencing the same static lib. So I am going to open project properties and go to C++ and just copy the same include directory from the Windows version to Windows Phone. Should be pretty straightforward. You might ask, why don't we do that automatically? Again, we don't want to mess with your project reference by default. And we figure it's probably easier for us to leave it blank, and you can manually add what you need. OK, so I need to go to linker and find the same library directory and copy over to Windows Phone. And one more is the actual lib file. So a couple of things I need to copy over, including the 2D and the 3D libs. If you start with the project template, it will be set by default. But if you add new nodes, we don't add that for you, so you have to manually add it. That's in the same spirit of not messing up with your file. OK, so now I should have everything set. And I'm going to run this on first try. Finger crossed. Let's see if it works. I am using the emulator here, which I already have it launched. And it's deploying. Copy over, and there we go. Thank you. That's a scary thing to do on stage. Oof. So you have the same feature here. You can rotate, and you still get the same XAML. Right? You can scroll. And if you don't want to customize, then just leave it there. You can completely share the XAML code. All right. Actually, there's one more thing I want to show you before we leave here. So one thing you might be interested is, OK, so we shared all the DirectX code. It's just happened that I did not use anything unique to any platform, so it's completely shareable. But you could potentially do some customization for each platform. Let's say you have a large file, and there's only one function you want to make unique for either Windows or Windows Phone platform. I still want to share the file, but I want to do something unique as well. So you can do fdef in your code. That's still supported. I can actually show you, hopefully. And if. So this is an example of something unique for Windows, but not on Windows Phone. This is basically to disable all the point of visual feedback for better performance on Windows Phone. So you can say, OK, if this is not Windows Phone, then enable this. If it is phone, then don't do it. The cool thing about using the universal project is you actually get context-aware support in IDE. Notice I just switched from Windows Phone to the Windows version. And then the fdef are now enabled. It knows which platform you are programmed against, and it will show you the correct code. And if you're using IntelliSense, it's going to have the same context. It knows which APIs you're using, which are available on which platform. So that is the benefit of using universal projects. OK, now let's switch back. Basically, we'll talk about two things. One is we have a number of templates for Windows and phone. And you can start with Universal App, which gives you the default nodes and shared. You can also start with one target and then add another target later and make it a universal app. Then we're going to switch and talk about some of the graphics diagnostics tools. Now we have the app running, and more than likely, developers like me is going to make some mistakes in rendering the scene. Some objects might be missing. Now you're looking for some tool to help you diagnose what is wrong. In 2013 RTM, so the tool we have, the graphics debugger, was first shipped in 2012. And in 2013, we added a number of enhancements. First of all, it now supports remote debugging. So if you are connected to a device or machine, you can debug right onto the remote device. You can capture frames of the remote device or machine and do analysis in Visual Studio on your local machine. The second thing we supported is compute shader debugging. Anybody using compute shaders? Yes, one. OK. It's basically extend DirectX to do regular computations, that's non-graphic. And because GPU is really, really good at dealing with large amount of data, and with single instruction, you can completely offload that work to GPU and save your CPU time. We added computer debugging in Visual Studio directly, so if you're using that, you can give that a try. And last but not least, did I mention it's now available in Express? No? OK. So the first version of this tool was shipped in Professional and above. In 2013, we made it available in Visual Studio Express for Windows. So now it is free for everybody to download and try out. Yay! Thank you. In Update 2, number of work we have done in Update 2. So we now support consecutive frame captures. In the previous version, we only support single capture with one capture gesture. I'll show you that in a minute. We also support programmatic capture, so you don't have to manually capture a frame all the time. The graphics event list has been enhanced. Now, the two biggest things are, first of all, you now can debug Windows Phone 8.1 apps, which has been a long time request from customers. The second thing, as I mentioned, we now have our first graphics profiler feature, graphics frame analysis feature. And I want to show you a demo here, which is to use the graphics diagnostics tool to debug a DirectX app. OK, so we are back here. Now I'm going to use a different app, which is also a universal app that have a Windows version and a Windows Phone version. And the majority code is actually shared. OK, I want to run this, and you'll see what it does. So it's a 3D city app that takes you through the narrow streets and look around the city. Something you might notice that is probably looking wrong here. If you look close, some of the buildings are completely black. Notice that? Looks like some of the textures are missing. Well, some render issues I cannot solve with the regular debugging, so I'll have to go use the graphics debugger now. I stopped the app. And this time around, I am going to start the app with the graphics debugger. So if you have not used this before, it is under Debug menu, Graphics, and Start Diagnostics. And the shortcut key for that is Alt F5. So instead of doing F5 to launch the app, you do Alt F5. And this is going to launch the app again, but this time with the graphics debugger attached. So you'll see that in the left top corner that says press the print screen key to capture frames. OK, so let's try that. Let's wait for a building that is completely black. OK. OK, I just captured the frame. Oh, you know what? I actually captured 3. It's there. This is the consecutive frame capture I was talking about. So previously, you can only capture 1 frame when you do the capture. Now we support up to 30 frames, because it is sometimes hard to precisely capture the frame you want. So we support consecutive frames capture, so now you can do one print screen and capture consecutive frames. And hopefully that will capture the ones that actually have a problem. As it's been captured, it's just take a minute to come back. Actually, let me try again. That's interesting. Oh, great. That's the problem. Yeah, I need a larger disk. Okay, let me try this one more time. I'm gonna shut down this. That will hopefully help. Okay, let's see how much space. Oh, that is why. Okay, good thing I have a backup machine. Is it up there? Okay, great. All right, this is the exact same app, and I'm going to launch this. Okay, and let's do a few frames. Capture. Okay. Now it's coming back. Oof. All right, so you can tell these are consecutive frames because if you look at the number there, 71, 72, 73, these are consecutive frames. Okay, now I have the frame back. I can start diagnosing what is wrong with my app. First thing I can do is to look at the graphics event list. This is something new in update that we provide the jaw call only view. So in the past, it was a flat list of all the DirectX events. Now that we captured in that frame, you captured. Now we have a view that is jaw call centric. So because most of the time, the only thing you're interested in is the jaw events. Okay, what has been output from the jaw call? And you can walk through this and look at, let me just minimize this. Look at which buildings are being output from this jaw call, and you can walk through it to find the problematic buildings. In this case, it is this jaw call that's been outputting these black buildings. Okay, once we found that, we can then click on a pixel in the frame and then say, okay, what is wrong with this pixel? Show me the history of this pixel, how we got there. Now, on the left side is a graphics pixel history window. And you can, again, walk through these draw calls. These have been filtered, so these are the only ones that are associated with this pixel. And then you can expand that node to look at the triangles that this pixel belongs to. Now, the first triangle has this icon there that said pixel was excluded because it failed depth testing. Why? Because I have multiple buildings being drawn on top of each other. So the one in the back failed depth testing because it will not be rendered, actually. So we can actually tell you that. And then let's expand each triangle and see what's in there. It basically tells you what are the shaders that are being applied to that pixel. There are vertex shaders, pixel shaders. If I use other type of shaders, it'll be showing up there. And then one more thing I want to show you before I start debugging is the pipeline stage window. This is a visual presentation of the graphics pipeline, which used to be like a black box. Something goes in there and something being output. Now we provide you a view to look into what is happening in each stage in the pipeline. So you can look at each of the stage and see, in this case, it's probably the pixel history is wrong because the texture is not being applied. Now, from here, we can start debugging our pixel shader. So what's it doing is, now it has launched my shader code, which is, in this case, HLSL. And now, as you would expect, you can, let me just close all these windows. And you can set breakpoint. You can step over the code like you would expect. You can F10. and walk into the code and see what is wrong. In this case, if you look at, okay, so the code went into this if statement, which is saying, okay, the color for this pixel is going to be coming from this code map 2, which is a texture. Let's walk through this code and see what the value is. So now you can hover over the variable like you would do in normal debugging and look at what the value is after we execute that code. Looks like all the XYZ is 0, which means it's all black, nothing has been applied. Now, I don't understand what is wrong here. Now, if I look at the texture, looks like nothing is here. If we look at other textures, for example, this one, CodeMap 1, it has a tiny icon there that shows you can actually look into what the type is. If I click on that, it will load our image and texture editor, which means this is a texture being loaded to CodeMap 1. But we don't get the same thing in CodeMap 2, which probably gives some idea of, okay, I am expecting for all these 4 textures to be loaded, but it seems like only one is loaded. Maybe I have forgot to load the other 3 textures. We can confirm that by going back to the event list and confirm that. So let's expand this draw call, which has also been updated in update 2. Now, we not only give you a view of all the draw events, but also we expand that draw event and give you a view into what are the inputs into this draw event. What are the outputs? What are the shader resources that are being bound in this draw event? In this case, if I expand PS pixel shader resources, you will see only 1 texture is being bound here. So apparently I'm missing 3. Some other improvements were made in update 2 is the constant buffer, for example. We show you, okay, this is your constant buffer. You can open that to see the buffer content. But what's even cooler is we now actually highlight the calls that are unnecessary, because we know all of the calls you make during that frame will tell you, okay, so this value has been set already by a previous frame, and this is a redundant call, basically. The other thing we add was, okay, now I'm looking at this object. I am also interested in who else also changed the value of this object. This draw call changed this object, and what are the other draw events? So now we have a modify list for this object that says, okay, in this case, there's another event that has also modified the value of this object. So you don't have to jump around to find these kind of information. It's all embedded in the same tree. Okay, so now let's try to fix the problem here. We know it's this draw event. I am ready to go back and look at my code and fix it. So I go event call stack. This is another feature in the graphics debugger, which could show you a list of call stack and take you back right into your code. So going there. And this is where my draw call is here. This is my code. What I'm looking for is the shader source set. So basically, I am making a mistake here. Instead of 1, it should have used the number of skins. That should hopefully fix the issue. All right, beautiful. Now we have all the textures applied. Yes. Now, one thing I want to show you here is, which unfortunately I am running on the Surface right now, which means it's not as powerful as this laptop. So if you look at the frame rate of this app, It's actually, on this laptop, it's going to be 60. Now on Surface, it's 30. If I try it on a even lower end device, let's say the phone, let's see how much that is going to be. I just need to set here and go to ARM. And I have a phone device here. I am going to try to run it on the device. Okay, if I am lucky, this should work. Switching to this projector here so you can see it. It is deploying in Visual Studio. Should come up fairly soon. Okay, there we go. Ooh, even worse on the phone device. See, the frame rate is hovering around 14, 15, something like that. So we had a perfect app on Windows, but when we target a low-end device, yeah, we have a performance problem. That's how our performance tool, the profiler feature, can help you in this case. So let me stop here real quick. We'll save that for the next demo. There we go. So just quickly recap what we have talked about. Capture consecutive frames. Programmatic capture, I have not had a chance to show you this, but basically there's a header file you need to include, and then you create this pointer that's PAPI capture. Once you have that, you can, in your code, say begin capture here, and it will start capture. And when the next present happens, the frame, it will be at the end of one frame. And we'll continue to capture until you say end capture. Enhanced graphics event list, I have talked about that. Remote debugging, I mentioned that. And we support all the architectures. You can run on phone, you can run on Surface or any machines. Computer-shaded debugging, have not had a chance to demo you this, but we have that support built in as well. So let's move on to the profiler feature real quick. So what I'll do now is continue using stack diagnostics, Alt F5, and launch that on the phone. Oh, by the way, I have a headset here. And I was told I should give that away. I cannot keep it. So I think I'm going to ask a question at the end. And whoever gets it first will get this phone set. All right, so let me switch to this device here. So it's again running. Now this time we have the debugger attached, so we can now capture frames. It's the same step in Visual Studio, and just go say capture a frame. You can capture multiple ones. So what you see here is because the app is already pretty slow, so it kind of stopped for 2 seconds, and now the app is continue running because the frame has already been captured. You can capture multiple ones when your app is running. And now let's go back to Visual Studio and see what's happening here. As you would expect, because it's pretty large log file that we are trying to transfer back from the phone device to this machine. Now, we not only capture all the joy events, the APIs that you call, but also including all the objects, including your textures, or the buffers or shaders, everything we need to recreate the scene. So that's why it takes a minute to, it's actually less than a minute, transfer back. Now we have the capture from the device. Because we have a performance issue with the device, now we can actually, let me stop this. We can actually use the frame analysis feature I was talking about to get the performance numbers inside the Visual Studio. Now, because this is running on the low-end device, this is a Qualcomm reference device, it's going to take a few minutes to run. So just to save time, I am going to show you to have this run on my local machine, which is going to be faster. But I also get to use this opportunity to show you another cool feature, which is now I have the capture from this device. I can actually take the capture and try to play it back on a different hardware, which is a pretty cool thing to do. I just need to switch back to Windows, and this is my local machine surface, and I'll do OK. And it's actually being played back on my local machine now. You'll see this here. I can run this. Now this is running the frame analysis, what it is doing. So we capture all the events for this frame during capture. So we are able, because we capture all the parameters, we capture everything. So we are able to send the same events back to GPU and say, run it again, and this time, give me timestamps for each of the draw events. So that's the first thing we are doing here. Second thing we're doing, we figure, well, once you got the base time for each event, what are the next thing you want to do? You probably want to tweak your code, change something here and there, and try it out again and see if it helps. So we figure, well, let's run some additional experiments for you automatically, so you don't have to go back and forth and change this and see if it helps. The third thing we do is we collect hardware perf counters from your from the hardware. So we have worked with our GPU vendors to implement these features in the drivers, which means this feature, in order to get all these features running on your device, it will require a phone 8.1 driver. So you have to have an 8.1 device for this feature to run. All right, so we have the report back. And let's take a quick look at what it is doing. Now, we have the first table. This is for you to navigate through your draw events. So we try to give you a sense of, OK, which are the most expensive events out of everything. So the highest bars are the most expensive ones. We also try to give you the same information in the table, which is we provide shaded rows for the most expensive ones. And first thing you will see is the baseline timing. 6.18 milliseconds for this one draw call to run. Now, because this is running on my Surface, the actual performance number I want to get off is from the phone device, right? I did not get to show that here, so you just have to trust me that I actually get it to run on the device that I captured earlier. So I can show you that here. It's basically the same frame, similar, but you can tell that this is taking the same draw call is taking longer on phone than Surface, which makes sense, right? That takes 27 compared with this one is 6 milliseconds. We also run a bunch of the experiments, like MSAA options, which tells you, OK, if I am using 2x MSAA, how much time this draw call is going to take. So basically, we tweak the pipeline and run it again on GPU and collect the data and compare the data with the baseline and give you a percentage. So basically, this is saying this is going to, if you use 2x MSAA, it's going to take 35% longer for this particular draw call to run. So you should, the way to read this is you should look at the most expensive draw calls and look at that row and look for greens. Because greens are the ones that will increase your performance if you do that, if you apply that technique. So these performance numbers and experiments are very hardware specific. So if you're looking at fixing the problem on the phone device, you should run it on phone. If it probably, in some cases, it doesn't match. Like one thing, the same thing you do on this device may not help on a different device. So that's why we have this change playback machine, and you can play it back on any device. So in this case, we look at bitmap generation. It says, OK, I am going to get a lot of performance gains if I do bitmap generations. Let's try that in this case. Let me open the texture files I am using here. Oops, not this one. It's in shared. And assets, textures. And I am just going to replace these with the ones that have bitmaps on. So bitmaps basically is a pre-generated texture file that includes multiple levels of resolutions. So if the scene is far away, you don't have to use a high resolution image. You can use a lower resolution. That's how it's going to help with your performance. But the downside of it is because it's pre-generated, includes different resolutions, your texture files are going to be bigger. So you have to trade off between whether you want quality or you want performance. OK, now let's try. Let me close this guy. Let's turn on the device and try to run it again and see if it helps. Switch to the device. It's deploying to the device. It's running. And there we go. A lot faster, right? Now it's 2526. This is just by using bitmaps. It matches what the report is telling us. We are getting performance gains by using bitmaps. So there are a lot of ways you can use the report for. It's a lot of information in there. We will have documentations to help you understand what each experiment means and how you should use the data. So let's go back to PowerPoint. Same recap, we are supporting debugging on Windows Phone 8.1, including the emulator and device. Frame analysis, which is new in Update 2, you can get analysis report for captured frames. We give you baseline timing, experiments, and hardware counters. And you can rerun that same report, same log on different hardware. And you can also export the results into your favorite Microsoft Excel, because it's a lot of data in there. All right, that's basically it. And the same slide I showed before. Again, we added a number of features in 2013 RTM, and we made it available in Windows Express SKU. And in Update 2, we are adding more. The main things are to support Windows Phone 8.1 development. You can use universal apps. You can debug on Windows Phone. And the last but not least is we now have a graphics profiler feature that helps you to give you some sense of how your app is performing and give you some suggestions on how you can improve your performance. With that, I want to show you two more slides, which is a sample solution we have provided online that's called 3D Starter Kit. It basically showcases a number of things that you did not get to see in my session today, which is model and texture design, how you convert the formats, how you load the assets at runtime. It has been updated for Windows Phone 8.1 and Universal Project. You can totally start with that. It's completely free, and you can start with that and build your assets on top of. The other thing that might be pretty useful to you guys is DirectX Toolkit. Think of it as a utility library. That makes it easier for you to work with D3D. Now it has built-in features for loading textures, models, draw sprites, text, sound, so you don't have to deal with the low-level APIs yourself. You can just use this library, which has also been updated for Windows Phone 8.1, which should be available by now on Codeplex. And with that, I think I am right on time to finish this. But this is my email. If you have any questions about all these features, just send me a mail. I'd be happy to answer those and keep in touch and learn about what you do and what features you would like to see in the future and all that. I'll be here to answer questions after the session, but I want to thank you all for coming to the session. Thank you for your time, and hope you got something. Oh, I have the headset to give. Right. I hope you don't mind to stay here for a minute for that. All right. Who still remembers the shortcut key for start diagnostics? I think this gentleman is first. Yes, you got it. All right. Thank you very much for coming, and enjoy the rest of you.